linguistics. He is from the GDELT project, the global database of events, language, and tone. Please welcome to the stage, Kalev Hannes Leetaru.
Thank you so much.
Thank you.
It's an honor to be here with all of you here today. Start my timer here. There we go. Thank you so much. It's truly an honor to be here with all of you here today at this amazing event. So what I'm going to talk about today is the GDELT project, and this idea of how we can use massive amounts of data and computing power and AI to try to understand the world around us. And this image, by the way, this is a real image. This is an actual photograph of something called the NOAA Science Sphere. It's a giant acrylic sphere. They hang it and they project from around it. And this is one of my data sets on it, showing the world going by. But it's really a metaphor for the work that I do, which is this idea of how do we essentially try to take this fire hose, this deluge of information that comes out each day, and make it accessible and understandable, just like you need in a natural disaster. There we go. It's really about taking news and converting it to data. And we think about, news is designed for human consumption, whether it's television, radio, imagery, or text. It's designed for people. So how do we have machines try to understand all of this? Next. Here we go. Back one. There we go. And it's really about this idea. You think about if we take all the news said in a given day, this is rewind the clock a bit, and we extract out all the people, the places, the organizations, be able to see the connections that tie them all together. And that allows us to begin understanding what's happening around the world. And most importantly, we have to look across languages. So historically, GDELT has looked at over 150 languages, very soon to be over 400 languages. And this becomes very important as we try to understand the world around us. In fact, the very first alert of COVID actually came from our data. 10 p.m. Eastern Time, December 30th, 2019, we detected in local Chinese language press in Wuhan, China, a SARS-like viral pneumonia of unknown origin. And at this point, it wasn't something that anyone thought anything of. It wasn't a major pandemic. It was a minor story. But by looking at local media in local languages, we're able to see those earliest glimmers and then follow them as they become bigger and bigger stories. And what's interesting as we look across the world is the way in which the stories that are told reflect each country's internalization of the world. So if you look here, this was the 2014 Ebola outbreak. And we can see here media tone on the bottom. So the top is total mentions in American media. And we can see that that goes on for quite some time. It's not until the first Americans get it that suddenly it matters and America cares about this story. But the more interesting graph is the one below. You can see it's very negative down there. In fact, I think the first CNN article was, if it comes to America, everyone will be dead within a month. Very uplifting things. But what's so fascinating there is, once Americans get it, the tone becomes more and more positive. And this is something that we observe across the world is in the US, and in other, especially in the US, there's this idea of America to the rescue. That once it affects America, don't worry, we'll fix everything and solve all your problems. And this is something they teach in journalism school, but we can actually see that. We can visualize that at scale. And I'll come back to this graph. This graph is going to be very important in a little bit with the earthquake. So let's set the stage here. How much does American media cover countries around the world? So this is the major American television networks, 2009, 2016. Darker colors, so darker red means more intense coverage, lighter means less intense coverage. And this is, again, American media. And we look across the world and we get kind of a sense of, the things that American media covers the most. But what's interesting is this graph. So this was generated for me in 2016 by the Google Trends team. And this was, in that year, all US web searches on Google, how often people searched about every other country on Earth. And what's interesting about this is almost perfectly correlated with the map we just saw. In other words, what the media talks about is also what people search about. Now, we don't know which drives which. We don't know if media coverage drives interest or interest drives media coverage, but the two are perfectly correlated with each other, which basically means that in order to generate interest about major stories, we have to get media coverage about it. We have to get the media talking about these stories, which doesn't necessarily come naturally. Now, if we look at mentions of Turkey over time, so the top graph is worldwide Google searches for it. We see the earthquake is the most attention it's got in almost the last 20 years. But the US graph is very interesting here. We can see the big spike here with the earthquake, but we can see a spike constantly every November. That's Thanksgiving in the United States, where turkey, the bird, is sold, is consumed. So what's interesting here is that this is not a search for the phrase Turkey. This is a search for Google's actual topic for the country Turkey. And what that's telling us is that this is one of the challenges, and this is one of the ideas behind this idea of using Turkey as sort of the sort of requested country name. We can see here worldwide searches for it in red compared to blue if we look across the two terms. So we can see it's still, but we can see in the US, it's really not being used. The US is still using Turkey, T-U-R-K-E-Y. And this has really interesting implications for us when we try to gather information about events around the world, to really use the phrases and the names that are being used. And this I'll come back to in a little bit. Now let's look at earthquakes. Let's look at earthquake searches in general. So how often are people searching about earthquakes, period, across any country? We can see in the last 20 years, the Turkey earthquake really received more coverage than almost anything else. We can see Japan, we can see China. And Japan, of course, because there was a big implication for nuclear power, which in turn had a huge implication in the US. But this tells a very different story. So this is US-based searches about earthquakes. And if we look here, we can see in the end that the Turkey earthquake didn't, so you look at Los Angeles, so look at LA there in the middle, Los Angeles. The LA earthquake, only 70 people were temporarily displaced, not even a day before they were back at their homes. That got almost as much attention in the United States as an earthquake that displaced, killed, and injured a huge number of people. And this, again, tells us that even the biggest events that have enormous impact, they don't get even attention or interest across the world. And this is where strategic communications plays that crucial role to get people interested, to fire them up, to let them know, hey, this is something you should really care about. And here's what's happening. Now, if you look at worldwide news coverage of it, we can see, if we look at earthquakes, we can see it's gotten more attention than anything else. But if you look there, you can see how fast attention dropped off. Now, this is something that we actually call it's sort of the disaster curve. What this is anytime a natural disaster occurs anywhere across the world, we actually observe a standard curve, which is about 72 hours of intense coverage, and then it rapidly falls off over the next 2 weeks. And this holds across the world, across countries, across regions. No matter where it occurs, no matter what country you look at, the coverage follows this same curve. Now, if we look here in the top is Google searches about the Turkey earthquake. And we can see that follows the curve that we would expect. This very brief surge and then straight down. But we can see media coverage does not. There's something different about media coverage about this earthquake than we've seen in most other natural disasters recently. And we can see it lasts a lot longer there. And we can see this also holds across television. So if we look at different television channels, in terms of spoken mentions, we can see the same thing. We can also see in America, this got very little coverage. Fox News only mentioned it about 200 times total in the last, 3 months now. And we can see, though, some countries, some media systems kept it along a lot longer than others. Now, if we look at the total seconds of airtime by day in which it was mentioned on the screen, somewhere on the screen was covering the earthquake, we can see also a similar pattern here. We can see, though, look at the difference between BBC News and Fox News. You look at the difference here, the media that we consume across the world. You can look at CNN versus Fox News there. If you're a CNN viewer, you saw a lot about the earthquake. If you're a Fox News viewer, you saw a lot less about the earthquake. But so let's zoom in here to the first week and a half of the earthquake. And we can see here, it peaks, but it should start dropping down. And it doesn't. And what explains this? Well, one thing that explains this is this graph. rescues. If we look at the covers that talks about someone being rescued, we can see it looks almost identical. And this is something that's very unique about this earthquake, is that in most earthquakes, you see stories of rescues, but they sort of pan out after the first few days. Now, sometimes that's because they can't rescue people. Other times it's because there's just no media coverage. The media consume newness. They need novelty. So what's interesting here is what you see here is this huge continued coverage of miraculous stories of people being rescued and recovered from the rubble. And this is something that's very distinct about this and really helps explain that long trajectory there. We can also see children. So a lot of these rescues were children that were these really miracle rescues. And what's interesting here, though, is you see the media tone get more and more positive over time. And going back to the other graph, this is actually a graph that we also see a lot in disasters, which is initially you see a lot of coverage of how many people were killed, how many people were injured, the impacts on people. But then you start seeing the global press start switching to, again, coverage of people being rescued, coverage of hope, of the future. And if we look at, now if we kind of expand to the first 3 months of this, and we look at aid, we can see again this mention here of aid pouring in from across the world. But then you can see this does kind of follow this tail downward, and you can see again another drop most recently with a lot of stories in the news. And this is again, this is a very important graph in that, to keep the story alive, to keep people outside of Turkey, outside of the region, to keep it alive, to keep them remembering what's happened here, the need for support, the need for help. This is a very important graph to interact with, to understand, again, the media moves on. It needs those news stories, needs things. Now, again, though, we can also see the tone of coverage, and the tone of coverage is becoming more and more positive as coverage just tends to cover things like some of the rescues, hope, and so on. And so it's very interesting. So this earthquake was very distinct in that regard. But one of the most interesting things is, as we look to it, so what I've shown here, looking at media coverage, looking at search information, the intersection between those two, that's a very important intersection between media coverage and search. Because the media can talk about something. The trick is how much people interact with that. So production versus consumption. But one of the interesting things is, in a natural disaster, obviously, you're confronted with this deluge of information that you have to be able to process very, very rapidly. And again, every second counts, and there's so much information, and it's so conflicting. And so one of the things that occurred, as the earthquake occurred, we were actually testing out the use of a lot of these new tools on understanding media at scale. And so we have a bunch of fascinating examples here in terms of what the future might hold for how we perform strategic communication during disasters. So back in the day, one of the things that we created was this idea of, if you take all the media coverage of an area, so carbon capture and sequestration, it's a clean energy approach. And one of the things we did here is we took all the coverage of that, and we extracted out every person named there. And we looked at how often those people co-occur with each other. And if you make that into a map, so you just take a ton of media coverage on a topic of interest, extract out all the people, and look at how often they co-occur with each other. What you get is a map of influence. And this becomes very important for communications, because when something occurs, you can turn to a map like this. So you can go to a database like Cision or any of these other media databases and say, well, who's the reporter in this news outlet who covers this topic? But it's just going to tell you who that person is. This will actually tell you how influential they are in that discourse. How much are they really driving the conversation in that? And this becomes very powerful, because when a disaster occurs, you can turn to something like this to say, who are the biggest drivers, the biggest influencers by country of interest, by topic of interest? You can do really interesting things. Once a disaster occurs, you start looking at the media coverage across the world. This is fascinating. So this is actually by a postdoc or graduate student. She was actually looking at refugees, but the same approach could hold for any topic of interest. What she did was she wanted to understand how refugees were being portrayed in the world's press. So what this is she starts with the word refugee in the center. And she says, what's the word that follows that? So if I take a sentence that says, refugees are, the next word would be are, but she is just looking at it now. So if it says, refugees are mostly children, you'd see refugee and then children. Refugee women, refugee community, refugee protection. So the next ring of the word that follows that, and then the word that follows that. and the word that follows that. And what's so interesting about something like this is it allows you to immediately understand how are they being contextualized. And so if you dig in, she has some other amazing graphs here. So you can see the places in the world that say refugees are a problem, refugees are criminals, versus the places that say refugees need our help. Refugees, refugees are part of our community. So the ability to understand the narratives, because this allows you think about it, when you're messaging, you never message into a vacuum. You're always messaging into a narrative environment. And it's a narrative environment that's this ever-changing river. It's a roaring river, and you're trying to message into that. So to understand in real time, how is this being contextualized? How is this story being told? And this was actually done for the COVID vaccine. So this was during COVID, a very similar environment to a natural disaster. A requirement that came to us was, we know a lot of the falsehoods that are spreading right now about COVID vaccines. So this was in a particular moment as the vaccines were being rolled out. And the mandate said, look, we know most of the major falsehoods that are spreading right now. What are the emerging ones each day that we don't know about that we need to keep an eye on and develop messaging strategies for? So what we did here is we took a day of coverage about COVID vaccines, in this case across 65 different languages, and we use a tool that clusters those together. Now, what's interesting is it knows that, say, an article about nanochips, nanochips in syringes is the same as microchips in syringes. And so we're actually able to use this graph then and overlay known fact checks on top of that. So if we have a fact check, for example, that says one of the major falsehoods right now was the idea that there's microchips in the vaccine that are going to do mind control. So you can overlay those on top of this and then see, oh, these clusters here, we already have fact checks for these. But here are the ones that we don't know about. Here are the ones that are emerging that we need to keep an eye on. And the best part is, because this is multilingual, we can see that, oh, this is spreading in this language, now it's spreading in the following languages. So it allows us to target how we think about and message into those. Television, of course, plays a crucial role across the world. And so in a collaboration with the Internet Archives, TV News Archive, we have selections from over 100 channels from 50 countries over portions of the last 20 years. We've been exploring how can we use these to understand what the world's saying. So this could involve keyword searching of closed captioning and spoken words, and you can generate timelines and graphs of things. One thing that we're doing right now for Ukrainian, Belarusian, Russian, and Iranian television selection is we're actually performing speech recognition in real time, near real time, within about an hour delay, and then translate that. So we use, and then translate through Google Translate, and then you can actually play back the clips with the English translations overlaid on top of them. And this makes it very powerful, because again, machine translation is far from perfect, but it's good enough that it allows volunteers and journalists and others to triage this and say, whoa, wow, that's really interesting. What are they saying there? And then a language expert can confirm what's said. But it suddenly makes it accessible to study, and we can now search what used to be unsearchable. We can also do really interesting things. During COVID, we were interested in who's telling the COVID story. Who are the doctors that are being interviewed on television news? So on most television channels, on the bottom, it says who the person is that they're being interviewed. Now, what's interesting, in a crisis like an earthquake, you could actually triage this in real time and say, well, who are the folks that are being interviewed on television about this across the world? Are there experts that we might suggest that people talk to that maybe have a greater expertise in a certain area? We can also look at, so this is something we looked at, of provenance. Where is the footage coming from? So in the case of COVID, in the United States, television crews can't just walk into a hospital and film. And so one of the questions we asked is, where's all this footage coming from? Because, for the most part, you can't film in hospitals. So what we found is, for a lot of the footage that we saw on television was actually stock footage. And what we did is we took a broadcast, we started taking broadcasts, chopping them up every second, extracted a frame, and then searched across the open web for that image. And then actually found, we actually triaged where they came from, and we could actually find, for example, if it's a wire image, we could actually get a description. So we could actually triage and compute the provenance of this. Now, where this becomes very interesting is we can take all this footage. So one of the things we did recently is we took a year of 60 Minutes, a show on Russian television, and we took a year of it, and we basically took every frame, and we compared it to every other frame over a year of television. So you can actually see what clips are being reused and where. Now, imagine in, say, a natural disaster, you could triage all the footage that's coming out. And you could say, well, what's new footage? So, you think about any natural disaster, sort of that iconic imagery that gets played again and again. And what you might be interested in is cataloging those. What are all these clips? So imagine applying this to, say, American television. You're watching American television. You can see, oh, look, they're playing the same clips. Here are the major clips. So imagine producing a report. What are the main clips that are being played on American television? Oh, look, today there's a new clip. What is this? Where did this come from? And if you apply this across many different channels, you can actually track it down to its original source. So it allows you to triage, even in the visual world, where's all this information coming from? You can also do, next slide. Perfect. So applying this to, say, the earthquake, we can do really interesting things. We can find clips, for example, that got a certain amount of airtime. We can scan the bottom, and we can see who's being interviewed, who are kind of the journalists that are being interviewed. This can also be useful to understand, well, what journalists are where right now around it. So, for example, if you want to provide additional support or additional aid, or you want to reach out with additional information to kind of know who's where, essentially. But then also, again, to understand what are the clips that are circulating there. Now, and then looking at AI, so using AI tools to understand whether that's the text on the screen, whether that's identifying the objects. So we can do very interesting things. We can take all that coverage of that earthquake, and we can tell you what percentage of that coverage is actually of the earthquake itself, of building damage. What percentage of that is people? What percentage of that is people being interviewed? What percentage of that is a newscaster somewhere else, like in the US, just commenting about it? So the ability to understand the visual world at scale, because you don't, in a disaster, you don't have enough people to sit just watching television all across the world producing these reports. Machines are really, really good at this now. We can also do fascinating things like visual search. So you can type in literally something like soldier in front of a Russian flag, and the machine understands that and actually generates that for you. And these are examples from Russian television, but the same holds in an earthquake. You would say, find me aerial imagery, find me imagery of buildings being destroyed. And this doesn't have to be television. You can feed in all that imagery that's pouring out to Twitter. Imagine taking all that Twitter footage and saying, is this video was just posted to Twitter, is this a video we've already seen before? So, okay, this is just another repost of a video, maybe it's been edited a little bit, but we've already seen this, versus this is new footage, this is something we need to think about or look into, and be able to search across that, wherever that footage comes from. Now, the real power comes in using things, large language models, so ChatGPT or Bard or any of these new tools out here. This is really the future of where crisis communication, especially in natural disasters. So here's an example we did during the earthquake where we said somewhere, so what you see at the top, that was literally what we handed ChatGPT, and the input was all the media that we were monitoring. And the original coverage for this was all the French government statements at that point, which were in French. And you'll notice the summary is in English. And so this ability to say, look at all the coverage, everything the French government's put out today, and summarize it in a concise paragraph for me. And same thing for the US, summarize all the stuff the US has put out today in a single concise summary. But this is where things get really interesting. So we said, make a table. So literally, that was what we typed in to ChatGPT and fed it all the news coverage that we monitored that day. And what you get back is a table. So you imagine just thousands upon thousands of articles in a brief moment, which all have all kinds of information. Maybe this one, and a lot of it's repetitive. You might have 100 articles that all say, Israel has dispatched some search and rescue dogs. And so again, like that's 100 articles, but what I need to do is see that once in a table, and it's able to do that. And this is real. This is not a mock-up. This is actually, and this was actually done during the earthquake itself. Now, again, right now there's still issues. These AI tools still hallucinate. They make things up. So this is still, you have to take things like this with a grain of salt. But it's rapidly evolving. And so the ability to do this, the ability to, and then the best part is to be able to do Q&A. So imagine during it, in real time, you can say, summarize the aid from USA. In this particular month, this is one moment in time. And you think about it, it's giving me a table, and it's summarizing this in text for me. So the ability to interactively ask these questions. So a query comes along, what are the USA commitments so far? Then we can look at things like, next slide. So summarized from the UN. So again, a similar query. And so you can just go, so you can interactively query this. So you can have anyone in your team, again, with all the different responsibilities, be able to query this in real time. Specialty things, summarize medical, search and rescue aid. And you can do different levels of detail. So what's interesting about this is I can say, give me a high level of detail as, say, a senior policymaker. I just want to know the general gist, versus an analyst who wants to know really, really nitty-gritty details here. the ability to do this in real time, to really summarize all that coverage. Next slide. And then this is really interesting. So these are example queries that we start looking at, how the tools can be used to do even more actionable querying. So what are the biggest needs for assistance? Now, you could do this, we've done these with news, but you could imagine this with field reports. Asking it, things like even additional medical aid, just triage all of this and tell me the summary statements that are in here. Next slide. Now, this is the really interesting one. So we actually have done a real demo of this top one here, not about the earthquake, but actually about COVID. So literally what we did is we fed tweets in, and we said, here is a list of fact checks. So here is a known set of 100 plus falsehoods. Tell me, does this tweet reference any of these falsehoods? And if so, generate a response tweet in the language of the original tweet, and refute it using the factual details below. And what's interesting is if somebody tweets and says, oh, COVID vaccines will control your mind, it's not just saying, oh, here's a link to a fact check that refutes that. It's actually writing something that refutes that specifically. It says, no, actually, there are no mind control vaccines in here, yada, yada, yada. Or, oh, well, what people are talking about was this tracking chip that was so they could check whether it was properly chilled or something. You can do really interesting things as well. So you can even do things like requests for medical assistance. So you could say, any tweet that's out there, triage it basically. So you can imagine in real life you want humans to do this, and humans will do this, but again, seconds count. So imagine a machine that's just monitoring. We've actually done some early prototypes of this, where it's just monitoring in real time any tweet that falls in that criteria. If it says, I have a broken leg, well, basically you give it a list, and you say, here are the different contexts for these different severities. So a broken leg, it'll respond back in the original language and say, oh, contact this phone number. It's someone has a crushing injury. Well, that goes to this number. What's interesting here is you can also have this summarize that into Turkish for your first responders, because you think about it, if you are, if this is a major disaster, if it's an area where you have a lot of people there, tourists and others, people may be tweeting in hundreds of different languages that you don't necessarily have immediate support for. And so, it's interesting because 15 years ago, when I first started working with some of the disaster community, things like this were amazing. Things like this, there was a lack of volunteers that spoke Haitian Creole. And so a lot of the tweets that were out there, there just weren't volunteers that were able to translate that. And so you had sort of these volunteers that were waiting, but they couldn't do anything about that. So the ability for machines to do that in real time, and also be able to triage even imagery, to say, oh, this tweet, this is an image, it's a new image, this has never been seen before, so this is probably real, not some piece of a lot of times a disaster, someone will find some image and they'll tweet it out and say, oh, look, someone's been injured here. Sometimes it's well-meaning. They just grab some random image. The ability to fight back on that and say, oh, well, actually, no, this image has been seen before. So this is a really interesting example that I'll end with in a second. So this was a demo that we did early on. So we did a demo earlier this year where we had ChatGPT monitor Iranian television and look for any reference to the nuclear accord. And we said, if you see a criticism of the nuclear accord, write a response to that in Persian. This is the translation. What's interesting about this is every bit of text you see here was generated by a machine. No human was involved in this. And this is where things are today. That, again, this is stilted. It's not the best of language. But you look at this, and you look at that prompt. That was literally what the machine was asked to do. Now, what's interesting then is we also asked it to make imagery for each of these responses. And what's fascinating about this is every image you see up there was generated by a machine. Now, you can see there's some oddities to it. But now imagine a natural disaster. Instead of photographs, you say make infographics. You say, so literally what you can do with these tools now is you can say, make an infographic in the following 5 different languages that maybe is a diagram that starts here and does this, and sort of like a Venn diagram. And you think about, you need graphic designers to do that. The tools can do this in real time. You could actually generate a custom diagram, potentially response to each tweet. Now, imagine you're in the middle of imagine you're a month out from the earthquake, coverage has fallen in the US. This, again, was ChatGPT. We literally asked it, write a persuasive op-ed for an American newspaper on why Americans should help those affected by Turkey's earthquake. What you see here, ChatGPT wrote every bit of that. Now, you can see, because it doesn't know anything about the earthquake, and because it hallucinates, you can see it only says 100 people and thousands injured. So that's why this would be a first draft. The machine, so you imagine your staff are basically overwhelmed. This is a great first draft to start with. And you can see it even said it's been a reliable ally. There are American troops that have been stationed here. It even adds in all this contextual detail. It was interesting. We tried this for different countries. It was fascinating. It actually, for each country, identified a connection between the two countries. This in 100 different languages, and you'll get it in each language. You can say,